I understand from working with some 7th grade students and parents that we might want a quick review of the rules of adding, subtracting, multiplying, and dividing integers. So I've printed just a couple quick problems here to take a look at. If you look, this says -8 plus -3. Students have learned a rule that will apply to that, but before we look at that directly, I want to show you a couple of strategies that they've been told to think about. If I'm at -8 on the number line, I would be moving behind 0 over here to -8. And when it says I want to add more negatives, my number is going to get more negatives. So I really am thinking about plus a -3 or adding a -3. Well, if I'm moving backwards 3 units, after -8 I'd run into -9, -10, -11. -11 makes sense to me using this idea of an open number line. So again, first I move backwards to this -8, next I move a -3 more, moving in the same direction because they're both negative. Another way students have learned to do this is to show me a model. And this is really to increase their understanding of why this works with the rules or the shortcuts. So if I have 8 negatives, we could model that with 8 little negatives. But I also have 3 more little negatives. So when I go ahead and combine all of these, I would say, well, how many negatives are there all together? The answer would be 8, 9, 10, 11 negatives. The rule that students have really learned to apply then, when it works repeatedly with both number lines and their model, is same sign, add, and keep. What that means is if both integers are negative, I can add the 8 and 3 and get that 11 and keep whatever sign was on both numbers. So negatives plus negatives make more negatives. Sometimes I tell students dogs plus dogs makes a lot of dogs. Cats plus cats makes a lot of cats. So negatives plus negatives makes a lot of negatives. Take a look at this next one. Here I have a negative plus a positive. If I look at this idea of an open number line, this one says that I should start at -7, which really means I need to move back behind 0 to -7. If this is my starting point, and now it tells me to add positives, I'm changing directions. I'm moving towards the positives. So I would then use this idea of an open number line and start heading this way. Well, I'm adding 15. If I added 7, that would really put me at 0. So next I'd need to add how many more? 8 more. So this idea of a number line and changing directions would also help me to find a positive 8. Sometimes we show this positive sign on the 8. Sometimes we just write 8 by itself. There's another way to show this model. We could actually use this idea of positives and negatives, kind of a pictorial approach. So I have 7 negatives, but along come 15 positives. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 positives. I've talked to students about zero pairs, or neutral pairs as they might be called. So over here I'll show you what one of those looks like. If I see a group of a negative and a positive, that is really equal to 0, or a zero pair. So could I find some zero pairs in here? Absolutely. I'm wondering if I could take each of these little negatives and pair it with a positive. There's a zero pair. Well, this type of pen doesn't show up, so I guess I'm going to keep using my big blobby pen. This negative and this positive combine to make another zero pair. If we keep going, I could combine these negatives and positives to make some more zero pairs. If you look, I also have a negative and a positive here that could kind of be combined. Kind of hard to grab those the way I wrote my model, but it would work. I have another negative and another positive that I combine 2 more. And another negative and another positive would make another zero pair. And again, I probably could rearrange my model a little bit better. Sometimes in the classroom we use a 2-sided counter, reds being my negatives, blacks being my positives, kind of like we talk about in our checkbook or in accounting. If you notice, once I take out all those zero pairs, I'm left with 2, 4, 6, 8. 8 little positives, meaning the remaining value is positive 8. The rule that we apply to this is sometimes called different signs subtract. So what does that mean? Well, one integer has a negative, the other integer has a positive. So I see that there are different signs. I need to subtract. Well, what does 15 take away 7? The answer is 8. But then I need to decide about what sign goes on here. So sometimes we say keep the sign of the farther number. So keep the sign of the farther number would mean which number is farther away from 0? Is 15 farther or is -7 farther? So we're actually asking who has the greater absolute value. The answer is 15. Or sometimes I just say, are there more positives or negatives? There's definitely more positives, so I'm left with a positive result. Lots of ways to model this. Open number lines are just a starting point. This pictorial approach with little positives and negatives and finding 0 pairs will also work each time. Sometimes it just gets a little bit tedious, and if your numbers are too big, that's why we need to move to this rule. Different signs subtract. Keep the sign of the farther number. Then you'll be exact. The students should be able to sing a really awesome song for you using those lyrics. If you take a look, the next one I am looking at is subtraction. I have 5 and I want to take away 10 negatives. So on a number line, I'm starting at 5. I usually use 0 because he's a nice marker of the difference between my positive side of the number line and my negative side of the number line. He's neutral, so I like to show that 0 here. If I started a +5, that would be somewhere this way. +5 would be right about here. So first I move a +5. Now I want to take away some negatives. Well, if I was taking away positives, remember, I would get more negative. But when you take away negatives, you actually become more positive. Sometimes I talk to students about this idea of if I started my day off kind of rough, well, maybe I had gum on my shoe. Maybe my hamster ate my homework. Whatever it might be, you started out negative, but when you take away negatives, maybe someone likes your shirt. Maybe they say, hey, the gum on your shoe is actually a really awesome color. Whatever it is, your day is becoming more positive. Something in your day has changed direction. So we are taking away negatives or becoming more positive. This is really the same as adding 10. So instead of subtracting a -10, sometimes we say let's add the opposite. Adding the opposite, meaning I'm going to add in the opposite direction. Well, the opposite direction of negatives is positives. If you look, you'll probably continue on this number line and land at a 15, and it should be a +15, by the way. Sometimes we just write that as 15, or sometimes we show this little positive symbol. Let's see if we can try this with our model approach. So if I have 5 positives, and I want to take away negatives, I don't have any negatives to take away, so what you're going to have to do is draw me some 0 pairs. 0 pairs. They have 1 negative and 1 positive to show a 0 pair. Let's see, I have 5 of them so far. I need 10 total. I can really draw as many as I like, but I'm kind of planning ahead here. I know that if I take away 10 negatives, I need to have at least 10 to take away. Well, here I see some negatives. There are 5 of them, and here's 5 more. And you really can show me these are going away. Goodbye, negatives. Well, what's left in our model? 5, 10, 15 positives. Yep, it checks out. The rule students have learned might be change a minus to a plus, change a sign of next. Change a minus to a plus, change a sign of next. Another way of saying that is add the opposite. So whenever I go to change to addition, I have to remember to change the sign of the next term. Oh yeah, 5 plus 10. Same signs, add and keep. Meaning positives plus more positives get me even more positives. Lots of ways to think of the subtraction. But adding the opposite, and then in this case, same sign, add and keep, these are the rules I ask students to think about when we move to the abstraction. Next, I have -20 and I want to take away 4. So again, just a quick number line. We'll call this an open number line, meaning I don't actually have to show the exact units, because sometimes that will throw students off. If you miscount by 1, then you have a wrong answer. So let's show this 0. He's kind of the buffer between my positives and negatives. If I start at -20, that really would be quite a ways back here on the number line. -20. So first I'd move to -20, heading to the left. Well, I want to take away 4 from you. I want to take away all of your 4 positives. Oh man, your day just went downhill, didn't it? If I take away your positives, it means things are getting worse. You're going to get more negative. So I could show this by showing I'm taking away 4. Maybe it's kind of treating it like a -4. Somehow I'm moving backwards. I'm getting more negative because you took positives away from me. Well, if that happens, I know this number line isn't long enough to show it, but aren't you going to land in a more negative number? Won't you be at -21, -22, -23, -24? That looks like my answer using an open number line. Let's try the same strategy, but let's try another strategy with the same problem, I should say. So I have negative 20. This is going to take me a while to draw. Great, here's my negative 20. 5, 10, 15, 20 negatives. I want to take away 4 from you, but that 4 is positive, isn't it? I don't have any positives to take away. The only way to model this would be with some neutral pairs or 0 pairs. I'm thinking ahead here. I really only need to draw 4 neutral pairs because I really need to take away 4 positives. Well, let's go ahead and grab those 4 positives that I just made with those neutral pairs and take them away. If you look, I'm left with not just the negatives I started with, even more negatives. So if I counted them up, 5, 10, 15, 20, 22, 24. In fact, I have 24 negatives using this model approach. Well, there must be a better way to get there. Do you remember how we talked about adding the opposite? This is how we apply an abstract rule, something that will work every single time without using my number line or without using my pictorial approach. So add the opposite of 4 would be negative 4. Oh, change a minus to a plus, change the sign of next. Sometimes, if you watch our math club video, it would say change the sign, add a line. So lots of ways to kind of memorize mnemonically different tools that will work for you here. So change a minus to a plus, change the sign of next. Or let's add the opposite of 4. Let's add a negative 4. Oh look, negatives and negatives get me a lot of negatives. I know that because of our addition rule. Same sign, add and keep. I really want you to keep multiple steps in mind, but most often when we're working with integers, if you see a subtraction, it's safest to change it to a addition of the opposite. Add the opposite and then apply your addition rules. So how does that work when we talk about integer multiplication and integer division? Well, this is a different matter. This really says I want the opposite of 12 groups of negative 5. This would be an awful lot of drawing. I did make students do it the other day, and I also made them work on a number line. Let's see. If I had 12 groups of negative 5, looks like that's 5 groups. I need 12 groups. You can see that this idea of drawing a model probably isn't the best, meaning it can be faulty. I can make a lot of errors if I have to draw a model that's too big. I could get out my two-sided counters, but this is definitely a lot of two-sided counters to be showing you today. But this shows me 12 groups of negative 5. Again, I'm saving this negative for in a minute, meaning in a minute I'm going to find the opposite of 12 groups of negative 5. Well, if you count this all up, you will notice that we ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. It's just like having 12 groups of 5. So 12 times 5 is 60, but these are all negatives, so it looks like I get a negative 60 from my model. This is where it gets tricky. If you have two-sided counters, it's awesome because you'll flip them all over magically, and you can find me the opposite of this. The opposite of negative 60 is a positive 60. The answer here is 60. It's hard to show that without being able to flip these. And even on the number line, I make the students move first to the negatives, and then we have to talk about the opposite of what they found. So tough to use a model in this. So here's another rule that we talked about. If the signs agree, you'll get a positive. Oh, look, he hates Brussels sprouts. Oh, I do too. It works out. We're going to get along. We're going to get a positive answer. So in this case, we would say the signs agree. We'll get a positive result. What about over here? Here I have a negative and a positive. I hope you remember that multiplication is commutative. So one way that I've seen students handle this is to change it to 6 times negative 8. Shouldn't I get the same answer? Well, if that's the case, I could easily read this as 6 groups of negative 8. Well, let's show a group of negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Got to do some double checking here. Again, kind of impractical. When we get this high in numbers, it's definitely concerning that an error could happen. but we'll give this a try. Here I have 6 groups of -8, and if you notice, I don't have to find the opposite of that at all. So 6 groups of -8. What did that get me? An awful lot of negatives, didn't it? It got me 6 times 8. Well, that's 48. And again, these are all negatives, so it looks like I'm going to get a -48 here. -48. Oops, actually, that would belong here, wouldn't it? Let's see if it works out this way as well. This would say the opposite of 8 groups of 6. The opposite of 8 groups of 6. Well, let's see here. If I know 8 times 6 is 48, I could think of the facts. What would the opposite of 8 times 6 be? Oh, instead of 48, I'd get a -48. So again, we can read this sign out front as the opposite of. Again, we could have modeled it another time. We could have modeled it with our positives and then had to find the opposite of that. That's kind of tricky without two-sided counters and being able to flip them quickly. And again, this is way too many counters to be working with. So there must be another rule. Well, do you notice that one of these integers is negative, the other one is positive? I call that disagreement. They disagree. And when two numbers or integers disagree in multiplication, you're going to end up with a problem. He hates seasonal allergies. Oh, he loves them. It means that he gets to spend extra time indoors. Well, if that happens, you know that they're not going to get along very well. You're going to get a negative answer. Another way that I've shown students to remember this is with a 3 by 3 table. This is really taking the abstraction and making a pictorial approach about it, or a visual reminder at least. So here I could say a positive times a positive gets me a positive, and I know that. I've been doing that since 3rd grade. 2 times 6 is definitely 12. A positive times a positive is a positive. And if you remember, we could fill in the negatives into this table with all the other openings. So what this tells me is a positive times a negative, that gets me a negative. Oh, I just saw that. Positive times a negative gets me a negative. And here I could try another one. I could say, what about a negative times a negative? Oh, that got me a positive. We saw that in the first example. Negative times a negative. Oh, they get along. We get a positive result. The one that I didn't model for you is a negative times a positive. But if you look, that kind of is this first problem before we rewrote it or before we looked at the commutative property. Negative times a positive still gets me a negative. Huh, good. This table is kind of helpful. I do ask students to quickly jot that on a test or a quiz that we might look at soon, and make sure that they can rely on that kind of as a mnemonic device or a quick mental reminder. Now we have division. There is no way I want to take 150 and divide by a -10. So what I might say to you is, what is 150 divided by 10? Well, hopefully you can see that it would go in there 15 times. But here's the problem. I want the opposite of that. This one negative is telling me, well, what's 150 divided by 10? And now find its opposite. Well, the answer has to be a -15. Again, I'm really moving to my abstraction. I'm using a fact family that I recognize or that I know, and then I'm applying this rule of an opposite. Let's take a look at another one. I probably could draw this one out pretty quickly, so let's try it. Here I have 20 negatives, 5, 10, 15, 20 of them, and I want to split them into groups of -4. So let's see. -4. There's a group of -4. Here's 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 a group of -4. If you notice, I was actually able to make a complete number of groups. We wouldn't say that I have a -5 groups. We would say that I was able to make 5 whole groups. This is interesting. So what do you notice? A positive divided by a negative, those signs don't get along. I get a negative answer. Oh look, a negative divided by a negative, I got a positive answer. Those signs got along. Does that work with this same table? When I had a positive divided by a negative, I got a negative. That's this first example over here. When I had a negative divided by a negative, I got a positive. That's that second example over here. And in fact, it's true that if you rearrange them and I gave you a negative divided by a positive, they wouldn't get along very well. You're going to get a negative result. This is just a few quick examples to help you with those basic integer rules. Students are now moving on to integer order of operations. So we're going to have to take these and look at long strings of them to figure out the final answer to an expression.